Let's continue with the union, intersection and complement of events. These are the basic relationships of the probabilities: complement of an event, mutually exclusive event, addition law. We will talk about these three laws right now, and then tomorrow we will talk about the conditional probability and the multiplication law. The complement of an event E is the set of all outcomes in the sample space that are not included in event E. This is the relationship. This is known as E prime. That means probability of E plus probability of E prime is equal to 1. For example, what is the probability to pick up an ace from a deck of cards? This is 4 over 52 because we have 4 aces over 52 cards. What is the probability of not choosing an ace? In this case it's going to be 48 over 52 because we have 48 cards that are not aces. And this is the second example. We have 5 red chips, 4 blue and 6 white. What is the probability that the chip is not blue? So if it's not blue, it has to be white and red. So 6 plus 5, 11. 11 over 15 is going to be the probability, or 0.733. Two events are mutually exclusive if they cannot happen at the same time. So as you can see, in this case set A and B are mutually exclusive. They don't have anything in common. If they don't have anything in common, the intersection, and we talk about intersection on 7.4, will be equal to 0. In this case the events are not mutually exclusive. As you see, they have a common area. The intersection exists. So let's go to see an example. Decide if the two events are mutually exclusive. Roll a number less than 3 on a die. Less than 3 means 2 and 1. Roll a 4 on a die. So in this case the two events are mutually exclusive. They cannot happen at the same time. You cannot have the same time 1, 2 and then to have a 4. So you cannot have the same time a number less than 3 and the same time to have a 4. So the events are going to be mutually exclusive. In this case, select a jack from a deck of cards, select a heart from a deck of cards. Don't forget, we have a card that's jack and heart, as you can see. So we have a point of intersection. The intersection is going to be the jack heart card. As a result, the events are not mutually exclusive. Now, if the events are not mutually exclusive, the addition law for the union, and union we use the word or, A union B or A or B, will be probability A plus probability B minus the intersection. Again, we cover intersection union on 7.4, and we talk about for the union we use the words or. At least for the intersection we use and both. So let's go to see this example. What is the probability that the card is a jack or a heart? So in this case the events are not mutually exclusive. We have 4 jacks, 4 over 52, 13 hearts, 13 over 52, minus 1 over 52, which is the jack heart. And we have to subtract 1 y, because one of the jacks is a jack heart, one of the hearts it's a jack heart. So we count it twice, so we have to subtract it once. So the probability is 16 over 52 or 0.31. If the events are mutually exclusive in this case, if they are mutually exclusive, the intersection is 0. So probability A union B is equal to probability A plus probability B. And one more time, for mutually exclusive events, I put it as a note, the intersection is 0. So in this case the probability to roll a number less than 3 or a 4, less than 3 it could be 1 and 2, so we have 2 over 6. Probability to have a 4 will be 1 over 6. So 2 over 6 plus 1 over 6 is 3 over 6, 0.5. One more problem. If you have a table the first thing that you have to do is to figure out the total of the rows and the total of the columns. So we have 49 male students, 51 female, 24 they study less than 5 hours, 46 between 5 and 10, 30 more than 10, total of 100. So every time check if the events are mutually exclusive or not. An easy way is that if they are mutually exclusive, you have columns or rows that are parallel. Otherwise, you are going to have a column that is going to intersect with a row. So in this case, the events are not mutually exclusive. So for this question, what is the probability to study between 5 and 10 or more than 10? As you can see, this is going to be parallel, the two columns. You don't have anything common, so the events are mutually exclusive. So the probability will be 46 over 100 plus 30 over 100.